So in this video, we're going to look at handling factors. For this, we use a case study example of the daily climatic data in Niger. So topic 1 goes through this data in a lot more detail, but as a quick recap, this is a case study example where we use some Niger data. This is a daily climatic data, which gives measurements for 4 stations. We look at 3 elements in these stations: minimum temperature, maximum temperature, and rainfall. There are other elements in that station, but for the purpose of this, for this case study example, into handling factors, we just focus on those 3. So here's the data, and this is the data in our instat. And here we can see we have 2 factors. We have name, which is the station name, and we have month, which is the month that the data is from. You can see how we have this daily data, and we've got every year, month, and day in the columns: year, month, ABBR, so month abbreviation, and day and month. You can then see that we have Tmax, our maximum temperature, Tmin, our minimum temperature, and rainfall, our rainfall. We can treat year as a factor, or we can treat it as numeric. That generally comes down to kind of what the question is. And that gets dug into in a bit more detail in what is a factor. And again, later in topic 10, we also look into whether we can, when to treat something as a factor. So what we want to do is we're going to just stack these elements, and the guide will go through these. There's how-to guides at the end of this topic, which will go through how to run these things in R Instat and R, so you don't need to worry about these specifics. But what we are going to do here is we're going to just stack the data like we did in the data reshape module. And we have element and value. So element is now whether it's minimum or maximum temperature or rainfall, and value is the value of that element. So we're first going to visualize our daily data for each station for these 3 elements. One way that this can be achieved is by faceting by station and element. This is a big idea that's come from the grammar of graphics. And actually throughout this course, when we use visualizations, we introduce them using something called ggplot. And that GG in ggplot stands for the grammar of graphics, which is a very big idea about how we can use layers in this grammar of graphics to build beautiful, powerful, very useful plots. And facets is just one part of that as well. And in there, the author says that facets are a way to split data into subplots based on another factor in the data. In my opinion, facets are one of the most compelling reasons for using the grammar of graphics. And so what are facets? Here's some facets. So the facets is this idea that instead of having all of our data in one plot, we can actually facet it up and have it in lots of different plots. So faceting is a series of plots in multiple panels. These panels are based on the combination of element and station in our case. And we can see that these 3 elements, the data at Niamey Aero starts in 1940, but for the other stations, the data starts at 1950. We can also see some cyclical trends in the elements fluctuating within the years. So here we have each plot here is a different station followed by a different element. And this is going across. On the x-axis, we have our year, and on the y-axis, we have our value. So we can see kind of, let's just look at Niamey Aero for Tmin, our minimum temperature, and we can see that kind of cyclical yearly trend of that temperature fluctuation, and similarly so with rainfall. We can see that there's a big spike here, and obviously not in a slide. You can zoom into these a little bit more, but also we can look at these in a much clearer way by actually, if we want to change the plot, instead of just being these multiple rows, to being rows and columns. And this is a lot clearer, in my opinion anyway. So here we've rearranged that last plot to instead have a series of plots in multiple columns. We've got our station on the x-axis. So we've got our different stations are going down here. So each of these kind of columns are our station. And then each of our rows are a different element. It's now easier to compare the elements between stations. So if we want to compare Agares to Niamne Aro, we can see that actually there's a lot more rainfall that seems to occur in Niamne than there is in the former. We can also look a bit more into the temperature, and we can see that this minimum temperature fluctuates a little bit more in Niamne Aro than it does in Agares. I've said that the wrong way around, sorry. Agares seems to fluctuate a bit more, because if we look at the difference between this minimum and this maximum, that's a lot greater in Agares than it is in Niamne Aro. I did confuse myself a bit there, so I'm very sorry for that. We can also, if we want, so here we have our stations going across and our elements going down, we can flip that. So we can now have element going across and station going down. And so in this case here, for our daily rainfall, this is not as useful because we can't really easily compare these different stations in their rainfall to one another. So that might be why I would opt for something like this instead when looking at rainfall. For minimum and maximum temperature, though, it could be argued that this is preferable. If you didn't want to compare minimum and maximum temperature between stations, but instead you wanted to compare them within stations. By this, I mean, for one station here, we're looking at their minimum compared to their maximum. For another station here, we're looking at their minimum compared to their maximum. Previously, we were actually looking at all of the minimums, comparing them across stations. So here we're kind of comparing between stations on their temperature. And here we're kind of comparing within a station on how these two elements differ from one another. These kind of facet grids are a sort of table of graphs. Each row corresponds to one variable and each column to another variable. And it gives us this kind of grid of plots. So let's keep looking at our temperature data, and we can facet by station, and we can observe the minimum temperature across all of the years. So let's look at our T-min variable, and we'll look at the minimum temperature across all the years, split by month. So along the x-axis here, we have our different months, and split by station. So each of our different plots are different stations. We have faceted by station. We've then also colored the mean temperature for that month across all the years. And we can see the sort of relationships that we have here. So for minimum temperature, we can kind of see that for Agares, it's more of a normal distribution, a little bit. Whereas for our other stations, there's kind of some bimodal aspect in there. There's kind of, you know, there's this peak of your minimum temperatures occurring around May, but then it kind of gently tapers off before decreasing, rather than having a peak which goes down as quickly as it came up. I guess what I'm trying to say is that it's not symmetric, which is interesting. And we can see how this compares for our different stations. And now we can also look for our maximum temperature, and we can now really see these kind of peaks and so we can see that there's a peak around April, May, mainly around April for most of them. For most stations, it's around April. Oh, no, sorry. For Niamne, it's around April, the peak, but for Zinda, it's around May. Here it's around April, And here it's around May, maybe even June. So we can see how our maximum temperatures change between the stations this way. And we can also see that kind of trend. You know, we have a peak, as we said, in the Amne, we have this peak in April, but we then have another peak later in October. Of course, this peak isn't as high as that peak is in April, and it's not as high as the kind of surrounding months for April, but it's still interesting to see this general trend. So overall, this was a small introduction to the power of faceting to visualize factor variables. Faceting enables the analyst to create a series of plots in multiple panels based on one or two factor variables. It can also be based on more. Why don't you try that out using the guides and tweaking the code? You can try that out for yourself to see how it looks. Faceting can then create these comparable, repeated plots. This makes exploring and analyzing relationships in the data across different factor levels a lot easier. Thank you.